Steel Profiles podcast is brought to you by AISC Continuing Education. Visit aisc.org/seminars to find a seminar in a city near you.
Welcome to another episode of Steel Profiles. I'm your host, Margaret Matthew, Senior Engineer in the Continuing Education Department at AISC. My guest today is Michel Bruneau, Ph.D. PE. Dr. Bruneau received his bachelor's degree in civil engineering from the Université Laval in Quebec, and then went on to earn his master's and doctorate degrees in structural engineering from the University of California at Berkeley. Michel is currently a professor in the Civil, Structural, and Environmental Engineering Department at the State University of New York at Buffalo. Professor Bruneau was the director of the Multidisciplinary Center for Earthquake Engineering Research at the University of Buffalo from 2003 to 2008. Michel also serves on the editorial boards for the Engineering Structures Journal, the Journal of Disaster Research, and the Journal of Earthquake Engineering. Professor Bruneau serves on the AISC Specification Committee on TC9 seismic design, as well as TC12 modular composite construction. Michel is the co-author of the textbook Ductile Design of Steel Structures, as well as the co-author of AISC's Design Guide 20 on steel plate shear walls. He is the author of numerous journal papers and conference papers, and is the 2012 recipient of the AISC T.R. Higgins Lectureship Award. Along with his technical writing, Michel is also the author of published fiction. His latest novel is called Shaken Allegiances. Welcome, Michel. Thank you so much for agreeing to talk to me today.
Thank you very much. It's a pleasure to be here and to have a chance to participate in your podcast series with the millions of people listening.
Millions, yes.
Yeah, I've already prepared my answer of 42 that you know of, so in case you ask me a difficult question, I can always say 42.
42, that's the answer to everything.
That's the answer to everything.
So you received your bachelor's degree in civil engineering from the Université Laval in Quebec. Are you originally from the Montreal area?
Actually, no, I'm from Quebec City.
Oh, really?
Yes, so there's a sort of rivalry between Quebec and Montreal, as you maybe know. I don't know if you're a hockey fan. In the US, it's more likely baseball, football, basketball, soccer. I mean, hockey is way down there after wrestling and roller derby.
Well, it's not quite that far down. I'm from St. Louis. We've got some pretty big Blues fans in St. Louis.
Okay, but you may remember there was a Nordiques and the Montreal Canadiens, and so that was a big thing. Of course, the Nordiques left, and they're now in Colorado, I think. They're at the Avalanche. But strangely enough, I was from Quebec City, but I was a fan of the Montreal Canadiens, so that's a problem.
Yeah. You then went on to study at Berkeley for your master's and doctorate. So what prompted you to move all the way to California?
I think at the core, I've always enjoyed traveling. So travel, sort of, my ancestors might have been frontiersmen or something. There's a lot of French-Canadian blood there, which is, they usually call them coureurs des bois, which is sort of British. Canadians of British origin would understand that word, even though it's in French. But I think the closest translation is frontiersman. So the guy with the paddle and going for the fur trade and
like Lewis and Clark.
Yeah, that kind of stuff. But after I finished my bachelor's degree, I think some professor says you probably should do a master's. And I said, what the hell is that? I don't even know what you're talking about. And so they explained the concept, and they said, if you're interested in steel, you should go to Edmonton. I said, well, Edmonton is far. That sounds like a good thing to do. And so I told that to a few people around, and they says, well, they didn't know that Edmonton had all of these names in steel there, like Laurie Kennedy and what have you. So to them, Edmonton was like an outpost, and they says, why do you want to go to Edmonton? Why don't you go to the US instead? I says, oh, never thought of that. So got a lot of literature sent in the mail, and then started to get information, and then I realized that the entrance fee at some university was way up there, and that's how I understood for the first time there were some things called private universities on this continent, because everything was public universities in Canada in those days. So that eliminated a bunch, and then you look at the public ones, and California sounded like a nice thing to do. And in Canada, they give scholarships to students to do graduate studies fairly generously. And the rules were such in those days that you could carry the fellowship abroad, so that was fortunate.
Oh, yes.
There's a lot of things in life that are chance related, right? They could have changed the rules then, and then I would have gone to Edmonton.
Yes.
So I ended up having the chance to go to California. And you're in your early 20s, and you see California as this road with a line of palm trees on both sides leading to campus, probably somewhere on the Golden Hills. And I truly enjoyed California, and it was a fun thing to do. But if you've ever been to Berkeley, once you get off the highway and you drive up University Avenue, there's no palm trees. and there's homeless people pushing carts and all kinds of stuff. And especially in the area called People's Park, which I think were in the 60s. It became a symbolic area that had to be protected so that people could manifest, I guess, and occupy the park. But from the 60s to the 80s, it's sort of the only people occupying the park were homeless people at that time. So, but it was fun, you know. I really loved California. It was beautiful. It was enjoyable. It's a mindset. And the discovery there was that faculty members were, for the most part, involved in earthquake engineering. And coming from Quebec City, which has a history, an ancient history, but an history nonetheless of earthquakes. And even when I was an undergraduate student, I felt a few magnitude 4s and that type of stuff. So I felt, oh, there's a connection here, and that's really interesting. So on the technical side, I got addicted there because I only went for a master and ended up staying for a Ph.D. because it was too addictive. And on the social side, it was fantastic. It was an interesting experience for a young person in his 20s, and my wife was with me. But there's all these stories, you know, also on the social side of Berkeley, right? So there was a fascinating place for all of these interesting social side issues. But on the technical side, it was really fascinating too. And then, you know, coming from a place like Quebec City, where it goes to minus 40 in the winter.
I was going to say, you must have loved the weather.
It's hard not to enjoy California. But honestly, after a few years, we start to miss the snow. It's hard to imagine, and I think people would think I'm crazy, but once you come from that kind of an environment.
I think if you're used to it, that you want the seasons, you want the different changes. So where did your career take you after Berkeley? What was your first job after you finished your doctorate?
Well, somehow tying to this idea of missing the snow, we wanted to come back to Canada, so I applied to a number of places. And we ended up in Toronto. There was a firm called Morrison Hirschfield. It had been recommended to me as one of the good firms in Toronto. Not huge, probably 150 engineers in those days. They had a wind engineering division, which had just split up from the company before I arrived, so that they were down to 150. The wind engineering division became RWDI, I think. And so what they were doing is bridges, buildings, commercial buildings, industrial buildings. A lot of working with law firms as technical experts that both, interestingly, both the person suing and the person defending would agree to hire them to sort of slice the problem in the middle and tell them the truth. So I thought this was interesting. So this was an interesting experience. They were doing things which I never heard of before, but you see them everywhere, and it's just that you don't realize it's engineered. These guide towers, so this is these 1,000-foot tall towers with cables that go around to stabilize them. So they were one of the leading firm doing that in North America. So I did not design the towers themselves, but there were issues with, that's one thing I never thought of before, because every industry is different. Once you get into an industry, you discover the quirks of that industry. A guide tower seemed, well, in those days at least, was designed exactly for the number of antennas on it. So you want to add an antenna, you have to reanalyze the tower and maybe strengthen it locally to, you know, the moment diagram has changed and all of that stuff. And so owners who had lots of towers would say, well, what if we're willing to take a bigger risk of having it collapse? Right? Because they're usually in the middle of a cow field, so if they collapse, it's not like anybody's going to get hurt, and they can redirect the feed. They have redundancy in the system. If the tower collapse, you won't even lose a second of television. You know, these dishes are all redundantly feeding across the landscape. So I was involved in a study where we recalibrated load factors. If they were willing to take 10 times more chances of collapses or 100 times more chances of collapse. It doesn't make that big of a difference in the load factors, interestingly. These probabilities go up pretty fast, but at least they didn't have to reanalyze the towers and reinforce after every satellite dish is added. So that was something that they enjoyed, and it ended up being implemented in the code. The one other thing that was interesting there is that this company would not turn anybody. So if you had a really crazy job and you'd call an engineering firm, they would say, oh no, we don't do that, but call Morrison Hirschfield, they'll be able to help you. So I got involved in some strange things that
that nobody else wanted to do.
Nobody else would do. And it would span, you know, it could be something very simple, like they want to add a bank machine into a bank lobby. Never thought of it, but in those days a bank machine was like a giant safe. And so they were very heavy, so they had to check the slab. The banks were good, they had drawings going back to the turn of the century, not this turn, the previous turn, the 1900s, right? And so you open the drawings and it says, steelcrete. And you say, what the hell is steelcrete? And so that's when you realize that experience matters in structural engineering. And so you'd go around the office and talk to the guy who was 80 years old and say, have you ever heard of steelcrete? He says, oh yeah. And he'd pull his handbook from a shelf and show it to you. And steelcrete, it's like you have a flat sheet of steel and you would cut slits in it, but offsetting them as you go from left to right. And so when you pull the sheet apart, it's like these Christmas decoration, it does all kinds of diamond shapes. Mm-hmm. And then you would dump that plate in the formwork and that would be the reinforcement.
Oh.
So, the amazing technologies in those days. Uh-huh. And another project that I think was interesting is somebody, as part of a film crew, obtained permission to use a theater downtown. And they were supposed to hang spotlights everywhere on the balcony. And they thought, maybe we should have that checked. And we've borrowed the theater. We don't want the spotlights to go through the balcony. Mm-hmm. So you get there and the first thing they say is, so is it going to be fine? Well, it's like going to the dentist, right? You have to open your mouth and then they can see. So you have to open up the balcony. Said, what? So the guy took a crowbar and started to pull up a few planks, but they were tongue and groove, which means they're sort of bricked inside each other, the planks. And so if you've ever tried with a crowbar to open up a balcony, you essentially destroy the nice finishes. Uh-huh. And so that's where I learned a lot of English words that I did not know. And in the end, they opened up the balcony and you look inside and it's burnt. All the structure was made of wood and it was charred.
Oh.
And so he says, okay, the theater burned down way back then. So you take a piece of steel and you start poking to see how deep the charring goes. And then you say, okay, that's the structure. Now what are the loads, right? Uh-huh. So ask the guys, okay, how heavy is your stuff? I don't know, Joe, how much does a spotlight weigh? He said, I don't know, 300 pounds? Okay, is that the biggest one you have? Is Big Barta there the biggest spotlight we have? Yep, that's the biggest one. So I said, how many are you going to have? I don't know, 20, 30, where are they going to be? We have 4 legs, and after that, I don't know, they could be anywhere.
Wow.
So that's where you learn about safety factors. And so
conservative assumptions.
And the importance of large safety factors facing large uncertainties, which is, I think there's a technical term for it called covering your ass. But in the end, we made it work for them, and they were very happy.
Yeah.
But so from 1,000-foot tall towers and to spotlights in a theater. So that was interesting.
Yeah. So a lot of interesting experience. Did you have a mentor that helped guide your career path?
That's an interesting thing. Literally like a mentor being a wise and trusted counselor who's sort of covering your back and giving you good advice constantly on a regular basis. Maybe not to that extent, but I think I may have had many little mentors along the way. On the professional side, there was probably a part where I had nothing, where I was just bouncing around, and then a part where I probably learned a lot from a lot of people. And to make sort of be less abstract, part where I was bouncing around was maybe before university. My father was a real estate broker, so we always had blueprints. So that got me interested in the construction world, but I'd never met an engineer before.
Really?
So when I asked, people said, well, you obviously want to be an architect. So I said, fine. So I will be an architect. So I went as far as I was doing okay in drawing, but I took classes in drawing, traditional stuff where you do the bowl of fruits on the table and the nudes, and one is more interesting than the other, of course, to draw. But in the end, there was an entrance exam at the architectural school. I think they only took 40 per year or something, and they would pluck you in the middle of a field in front of a building, and you had to draw it. And that part went okay, because I sort of had a reasonably photographic memory or visualization, I don't know how you would say it, in black and white, anyhow it worked. Then there was a part we had to create downtown streets in color. And there my skills were probably at the level of a 10-year-old. With crayons probably, with contrasting colors that make no sense together. So I don't know how I managed to be accepted, but I got accepted. But interestingly, I didn't think that this was the right place.
Did you start?
I started.
You did? Okay.
I did. I was there. I bought the whole drafting table and all the tools, and I was there for a week. During that week, I thought there was a lot of subjectivity there as to what was acceptable and not acceptable as architectural concepts. So anyhow, it was an interesting week. And then we had the first static class. And I remember the professor walking in and says, don't worry, it's mathematical, but just to give you an overview of what it's about, you're not going to be doing that stuff anyhow. This is going to be done by the structural engineer. And I said, what? And so I chatted with that professor after class, and I crossed campus and went to the civil engineering department.
Wow.
And I knocked on the door of the chair and I said, you know what, I think I made a mistake. He thought I was crazy, but he was kind enough to consider that on its basis and on its merit. And he says, why don't you sit in the classes and I'll see if you're admissible within the next few days. And then he said, fine, you can stay in the program.
So that's all it took was a week in the architecture department.
Yeah, it didn't last very long, unfortunately. So that's what I mean by bouncing around, maybe. But once, of course, in the field of engineering, there's always all kinds of individuals giving you good advice and directing you left and right. And I think professors do that sometimes without even realizing. So that having a mentor, like a guardian angel, working behind the scenes or in front of the scenes and guiding, maybe not so much. Of course, professors and former employers have written lots of good letters of recommendations, without which I probably would have never been able to get to the positions and what have you. They have guided and saying, why don't you do this, and why don't you do a master, right? Mm-hmm. That's good. But I think I prefer to think of it as many, many mentors that in some ways have played a role. I can think of Denis Beaulieu and André Picard, who were the professors who taught me steel. Mm-hmm. And they wrote a book about it, and they were engaging to that topic, and so they gave me the flavor, the desire to pursue steel more than other materials, right? That kind of stuff. They guided me to maybe some of my summer jobs. I can think of Peter Buckland from Buckland and Taylor, who was probably my first professional practicing engineering job, right? Mm-hmm. Peter Taylor had an amazing outlook on life, a good sense of humor, could make it clear that engineering is not production, but engineering is thinking. Mm-hmm. So the whole process was about thinking how to do the thing right. And so that was it's sort of mentoring in some ways. I think my first job was not very much thinking, but interesting there. He said, why don't you go with this engineer? There's a bridge to inspect. So the bridge was close to the office. It was the Lionsgate Bridge in Vancouver, which is a suspension bridge. So I follow this guy, and we walk up the approach spans all the way up to where the cable starts on the tower. And then he says, here. So, here what? And then he goes over the railing, and I thought, well, that's a strange place to suicide. You should do that from mid-span or something. But anyhow, there's a ladder on the other side. He goes down the ladder, so I follow him, and we end up under the deck on a little catwalk, or a traveling catwalk, I guess. And you've got these safety belts. So I clipped myself on the catwalk. So I had a little bit of a vertigo, is that how you say it? Mm-hmm. Yeah, so a little bit of vertigo. And so I clipped myself on the catwalk to feel safer. And I said, what are we here for? He says, well, we're here to inspect the catwalk because the maintenance workers don't want to come on it anymore. It's jammed and they're afraid it's going to fall. And I said, that's a good thing I'm clipped on it.
Yeah.
This way I'll not only fall, and I will sink together to the bottom of the bay. So mentors, in addition to my professors and my employers, I think many of my contemporaries in some ways are mentors. I can think of Mike Bartlett, who's a good friend. He's shown me, not on purpose, but I could observe how he was working, and he's working with little models sometimes to understand physical behavior, or people like him, when I see their calculation, the sketches are so wonderful, the calc sheets are so perfect, it puts me to shame, So there's many mentors in that respect. And of course, all the people in TC9, without realizing it, are mentors, because I learned so much from them.
You're currently a professor in the Department of Civil, Structural, and Environmental Engineering at the State University of New York at Buffalo. So how long have you been a professor, and what made you want to go into academia?
Interestingly, when I was doing my Ph.D., I would tell all my friends and my professors that my goal after graduation was to go back to consulting practice. And I did. I went back to a practicing engineering firm in Toronto. But I would keep in touch with my friends who had graduated at the time, more or less at the same time as I did, and many of them were in academia, and I would chat with them. And one good friend of mine was Pierre Léger, who was in Montreal, and I would drive from Toronto to Quebec to see family, and I'd just stop over and we'd chat about what we're doing respectively. Interestingly enough, that's, I think, talking with Pierre, talking with others, is when I discovered really what is it the professor does, which I had no idea. After 3 years in industry, I thought, well, maybe it would be worthwhile to try to get a professor's job and see what it's like, because it's a long process, it takes a year. And if I like it, good. If I don't like it, I can always come back to and industry. It doesn't take a year. Usually, great, you get the job, and you say, when can you start? And I said, tomorrow. And I said, that's fast enough. Can you start yesterday? So that was the plan. So I ended up at the University of Ottawa. I've been a professor ever since and never looked back. And maybe someday I'll go back to industry, I don't know. But for the time being, I've enjoyed doing that. In fact, I have to be careful because I think in the first years I was a professor, people would say, how are things going? And I say, oh, I'm having a lot of fun. Mm-hmm. And they would think I'm goofing around all day. So I had to tone that down. It was being misinterpreted because I think what I should have said is that working 80 hours a week does not bother me a bit when you're your own boss.
Yes.
Your own boss can be a tyrant if it's you.
Well, knowing what you know about the engineering profession, since you worked for a consulting firm, and then also being a professor, what's the best advice you have for graduating students this spring that are entering the real world?
Number one advice I give to all the students: enjoy what you do. I mean, life is short, amazingly short. And it looks shorter the closer you get to the end, actually. And if you think of a week as 168 hours, and you're liable to work easily 80 hours a week on some jobs, especially in engineering, and sleep is 50 to 60, and food is another 10, and you sort of realize there's not that much free time left. So 80% is about 50% of all the hours in the week. If you hate what you do, you have joined, apparently statistics say 95% of the people do not like their job. It's better to be in the 5% who do like what they do. That's maybe a practical reason, but the pragmatic reason is that if you like your work, you won't count hours. And if you don't count hours, you'll do something that you enjoy and you'll be good at it. And if you're good at it, good things will happen. And the opposite is, of course, true. If you hate something, if you do something you hate, you'll be bad at it and bad things will happen. So sort of a very simple philosophy of life. I mean, don't do good work, don't worry, good things will happen, right? Mm-hmm. The second thing I would tell them is there's more to life than engineering. Having said that, you have to find that there's other things than engineering in life, and it will vary from people to people, and I think life is a one-shot deal, and you've got to enrich that experience any which way you can. And what you do in the other things might have beneficial aspects on your work, of course. The third thing I would tell them is remain humble and beware of people with big egos. Mm-hmm. I won't expand on that. There's a thing on my board in my room that every grad student knows very well. It says, be ready to answer the question, why? It's not enough to get an answer. You have to understand why this is the right answer. Mm-hmm. That's a typical question, and that's what I mean for technical stuff, not for philosophy of life or meaning of life type of thing, because that's a tricky thing to answer why yes. at that level.
It's 42.
It's 42. We've talked about it earlier. But on the technical side, at least, we don't want to do things blind, because the minute we do, it's not engineering anymore.
Right.
I always looked at the senior engineers. Without computers, they would know what the answer should be, more or less.
Yes.
And not because they were odd guesses, but they had these little things on the back of an envelope, simple equations of period of vibration, so there you would get the computer printout, on a suspension bridge. In the old days at Buckland and Taylor, you had this huge printout that was 1.5 feet thick, and they would flip to the last page and look at the number, and they would know if the run was good or bad. That's experience, and we're in a field where experience matters.
Yes.
And the immense admiration for these senior engineers, because they are the ones who have the most experience. Mm-hmm. And they're the ones who can tell you often the why. But in research, we never know the why ahead of time, and it's dangerous to end up with generate lots of results. But I think it's not the number crunching that matters, it's very much an understanding of why things behave the way they do.
Yes, absolutely. So you've traveled all over the world after major earthquake events doing disaster reconnaissance work. So what is that work like?
Interesting.
I would imagine.
And exhausting. I think my way to do it is sunrise to sundown. I usually like to team up with individuals who work the same, because it's like a reverse experiment. We spend a fortune to build a specimen and test it in the lab, and then we look at the results. But we know what the specimen is, we know what the expectations of behaviors are, and if they're not, we at least have a sense of how it was designed, the specimen, and we try to understand what happened. An earthquake provides hundreds of specimens. You get the results, but you don't know what the experiment was. So it's a sort of a reverse engineering process, and it's fascinating. Of course, one has to be prudent in the first days following an earthquake, because there's aftershocks, and so I will go inside steel buildings. I will not go into buildings made of shoddy type construction.
So are you often in danger? I mean, are you...
No, I won't go into a building made of shoddy type construction. I think one has to be careful in those things. I think after the Christchurch earthquake, I had the privilege of doing part of the building assessment with some engineers in New Zealand, and we did pretty much all the steel buildings in downtown Christchurch. And every earthquake brings new lessons. Mm-hmm. There's a lot of the old lessons repeating themselves, but it's always interesting when there's something new to learn. I think the Kobe earthquake was extremely rich in information on the behavior of steel structures. The Northridge earthquake had just happened a year before in California, which had provided a lot of knowledge, I guess, of possible undesirable behavior of moment-resisting frames. But because moment-resisting frames were the most popular type of steel construction in the Los Angeles area at the time, it didn't say so much about the other types of construction. So the Kobe earthquake was rich because the Japanese had a lot of brace frame, so it allowed to see a little bit how these systems behaved to a greater extent. The Christchurch earthquake, not as severe as the Kobe earthquake, had a couple of surprises in it, in that a couple of eccentrically braced frames had fractures in their links.
Oh.
And that was a bit of a surprise. A number of eccentrically braced frames behaved very well in the Christchurch area, but those particular two are sort of the first time we believe that eccentrically braced frames have been A, solicited strongly during an earthquake, and B, that a few of them, of all of them that were there and that behaved quite as expected, that a couple of them fractured. And so it's going to be interesting to see the follow-through and to get, they're going to be cut out of the frame and tested at the University of Auckland and the University of Christchurch in various degrees. And we'll learn something from there. These are not fatal in the sense the buildings were fine. In fact, they were ready to reopen after the earthquake, much faster than a lot of the other buildings. But we need to learn from that. We need to understand what happened in those particular cases to make sure that practice is improved.
You're the 2012 recipient of the prestigious T.R. Higgins Lectureship Award from AISC for your paper on steel plate shear wall design. Can you tell us what your paper is about in a nutshell?
In a nutshell, steel plate shear walls.
That's a nutshell.
In a bigger nutshell, I think the citation referred to papers in the AISC journal and in the Canadian Conference on Earthquake Engineering without singling out specific papers. So I didn't dare to ask because I was afraid they'd read them again and change their mind. But I think there's a group of papers that have happened in the last year and a half that deal with capacity design of steel plate shear walls that have been co-authored with Bing Q and Jeff Berman and Ronnie Purba. So there's plastic moment modeling of these walls using that information to get better free body diagram information and then that is used to perform capacity design on these walls. And it provided a much better understanding actually of how the beams and columns, or they call them vertical boundary element and horizontal boundary element in steel plated shear walls, provided a better understanding of how they should be designed so that the capacity is not exceeded and that the system performs as intended. So I suspect that these are the papers that are being referred to in the citation, as well as information on perforated steel plate shear wall, which is sort of a new way to do steel plate shear walls by turning them into Swiss cheese, more or less, but in a regular way with a pattern of holes as such that it creates a clear direction for the diagonal tension fields that develops in the plate while reducing the strength of the plate. And why would we want to do that? We'd like to do that in low-rise steel plate shear wall buildings where calculations may dictate that we need maybe a 2 millimeter steel plate, but hot roll plates are not available in that thinness, and the engineer wished to continue using the hot roll for the ductility it has and for the weldability of a thicker plate, right? So by not being able to go thinner, what we have to do is reduce the area otherwise, and by strategically locating these holes in the plate, mission accomplished. Now, you could argue, why don't we just put a 4 millimeter plate and it's stronger, and so we get twice the strength we need, and it's not a bad deal. Well, the bad deal comes when you do capacity design, because you have to design the surrounding beam and columns to resist the full yield strength of the plate. So if you double the strength of the plate, it's cheap, but again, you have to double the size of the HBEs and double the size of the VBEs, and that's not cheap. So I guess in the end is a new system that has been introduced in the AISC seismic provisions, and this might have had to do something with the papers that are cited there.
Well, that sounds fascinating. I'm really interested to hear your presentation on Friday.
Thank you.
I'm told that the Higgins jury noted the impressive extent and breadth of your contributions as a researcher and engineer, and they wonder, how are you able to be so diverse and active?
That's an interesting question, and in fact it's an interesting perception because I never thought of it that way. It sort of strikes me. In fact, if I think of myself, I see quite the opposite. I see myself as distracted easily and probably procrastinator, and in the sense that it takes me an awful long time to make a decision. The good side of it is once it's made, I don't look back, I'm comfortable with it. Mm-hmm. But anyhow, so it's a combination of why would I be diverse and active? I don't exactly know. I can think of possible reasons. Then to be sure, I'd probably have to see a shrink or something. But it might be that I can't say no easily, so I get sucked into a lot of things. And so I have to work on saying no, that definitely. It may be working too much, or it could be stupidity. I was trying to think, when is the last time I worked 40 hours or less in a week? And after some brainstorming, I came up with 1979. And it's bad. I mean, one should not feel guilty working less than 60 hours a week, it seems. But it happens.
Maybe bad for you, but nice for the industry.
Oh, that's a nice way to say it. Another possibility is that I need change. If I don't do things different, I go crazy. Mm-hmm. And since I'm already a bit crazy, it doesn't help. And the last thing possibly is that I'm driven by a lot of crazy ideas. Once they're there, I feel like I have to try them. Mm-hmm. It's the only way I can get rid of them. So, for example, crossed my mind to write a book called Ductile Design of Steel Structures, working with a few colleagues. If you think about it rationally, it's not a wise thing to do because the amount of time you put into writing a graduate level textbook compared to how much money you'd make doing consulting work at the same amount of hours, you're in a serious deficit. Mm-hmm. Right? It'd be a lot more rewarding consulting than writing a textbook, especially a 900-page textbook right now. But it felt like the right thing to do. Doing it, the idea is now taken care of. And I think in the end it's a good outcome because it's a service to the profession. And as a professor, we're supposed to serve the profession in some ways. And now I have my class notes for the next 10 years.
So it works out well.
So it all worked in the end. But it's a difficult question. An uneasy thing for me to answer because it requires me to talk about myself. And I'm doing it now. It's very unusual because I'm not usually good at it. I'll remember when I graduated from my undergraduate degree, we had to write a funny line or something in the yearbook, right? To say something that people would not expect. Mm-hmm. Okay. I said, wow, I'll write that I was the author of the top 2 radio shows in Quebec City. Nobody believed me. A guy came up and he says, where was that? I says, well, this radio station, which was number 1 in Quebec City. I will prove that you're wrong because my wife works there as a secretary. Mm-hmm. So he asked me 5 questions about the station. I told him exactly what the answers were. Talked to his wife. She confirmed it. They could not believe, okay? Because I never talk about myself. It's funny. I was in the classroom and somebody, oh, did you listen to this last night? Didn't know I was the guy who actually did that radio show.
Mm-hmm. Wow.
So. And so I stayed there for a couple of years and did other things, but that was a nice summer job. And,
wow.
Yeah. So
very diverse.
Fun. It was fun. It was fun. But that just shows that nobody knew, mm-hmm. and that was fine with me,
You serve on the AISC Specification Committee as well as on many other code writing committees. Why do you think this is an important use of your time?
For a number of things. It's amazingly instructive. It gives a chance to get the point of view on various topics from practicing engineers, from academics, and from fabricators whom I look up to. These are very well-versed individuals in what they do. So it gives me a better understanding of the end product. I mean, I work with steel, I do research on steel, I teach steel, and it's valuable input to hear what these experts think. So I'm like a student when I'm on this committee. Mm-hmm. The second thing is I'm just trying to make a humble contribution to the profession, and if there's stuff that we do that can be useful, then great. If perforated steel walls end up in the code, that's more important, I think, in terms of service to the profession than having a paper on perforated steel plate shear wall that would be cited, I don't know how many times, but not in the code. The other thing that it is interesting for is that it's always a surprise to see what is of interest to the profession. Some work we did on eccentrically braced frames was for eccentrically braced frames in towers of bridges. The link of an eccentrically braced frame of a conventional type has to be laterally braced, so there's not lateral torsional buckling at high inelastic levels of deformations. Well, in the bridge tower, brace against what? A couple of clouds or air? So you're short on bracing. So we did something which we used a built-up box for the link and of course the beam continuous to the column, because boxes have good lateral torsional buckling resistance and they don't need to be laterally braced.
Right.
So we tested it, it worked, and we thought this was going to be used in bridges, and that's where it ended up being used actually. But to my surprise, on the AISC code committee, a practicing engineer says, no, I can use that in buildings, in atriums, in this location where I can't brace and this and that, and I would have never thought of it. You know, that would not have never crossed my mind, but this is what I mean by surprises of what is of interest to practicing engineers, because they deal with tons of clients and they have everyday needs.
Sure.
And they know the market, and it's an amazing good thing to be able to learn from them.
Besides being a distinguished member of the engineering community, you're also an award-winning fiction novelist. This would seem to be an anomaly in engineering circles. So what inspires you to write fiction? What do you get out of it that you don't get from being an engineer?
I think the word anomaly is interesting because it sort of stereotypes. If you think about it, it says
Well, yeah.
engineers are one-dimensional individuals. And there's a feature in the modern steel construction, I think the last page shows that it's not the case,
Yes,
right?
yes.
And every week, every month, I mean, you have a different illustration of that. It's always fascinating. In fact, one of my colleagues at the University of Ottawa, Hiroshi Tanaka, who is a wind engineering expert known worldwide, was also first viola in the Ottawa Symphonic Orchestra. Talk about multiple talents here. I think it's not anomalous. I'm amazed by the fact he was in the orchestra, and this guy was really good. And I asked him, I says, what attracts you to classical music? And he said, well, in engineering, we do concrete and steel, and that stuff's going to be there for decades, centuries. It's tangible. He says, in music, once I'm done, there's nothing left. And it was a Japanese guy, and I guess it was this yin and yang balance there that was appealing. Having said that, I think engineers are multidimensional. So my other thing than engineering is writing. Why write? I don't know. It seems to be part of me, so I can't say why I'm me. But I can't stop writing. I don't know why I write. I'm just effective like that. Sometimes people say, when did you start to write? It's like asking me, when did I start to see in color? Right? I don't know. It's always been there. It's always been there. Short stories in high school, a little novella when I was 18 that never wanted to publish. But then I got distracted by engineering and I became very passionate about it, and that takes time to get back into the groove of it. But why, the question being, why do I get out of it, and what inspires me? I think it's enjoyable to craft a good story. Should be fun to write, should be fun to read. I understand you read it.
I did.
I hope you enjoyed it.
I just finished it.
Okay, I hope you enjoyed it.
I did.
Yeah. But beyond entertaining, it should be something that leaves you with things to think about too. If you get out of it, then you say, oh, it's interesting, and I never thought it could be that way, and what does it mean, and the implications, and well, that's even more fun. And I think Shaken Allegiances, you may or may not agree, but I think you should get out of that one thinking that if everybody is self-serving, it's not a good path to follow.
Yes.
We'll end up, if we have more of the CEOs which get $1 million bonuses by firing 15,000 employees so that their profit to cost ratio goes up so they can justify $1 million bonuses, we're not going in the right direction.
Right.
So I think there's no CEOs in Shaken Allegiances, but there's a lot of characters that converge to the epicenter, and they're all doing that for their own sole benefit, and that creates interesting situations.
Yes. So Shaken Allegiances is your latest novel, and its events center around a major earthquake in Montreal. Is it possible for an earthquake of this magnitude to actually occur in Montreal?
Yes, actually. There has been earthquakes in Montreal in the past, We could argue about the precision of a magnitude 5.8 earthquake when it happened in 1732, but that's what it's currently pegged at. It's been more frequent in Quebec City or in the vicinity of Quebec City than it has been in Montreal, but it's still likely in Montreal. Montreal is at the intersection of the western Quebec seismicity zone and the St. Lawrence River, which has its own risk. In fact, I think the saving grace for Quebec has been the low population of the province and many of its areas. There was an earthquake in 1988. It happened in the middle of a part of Quebec which had been predicted to never have earthquakes, and it has a magnitude 6. So it shook a few moose, a few squirrels. It's in the middle of a national park. But interestingly, that same earthquake, 300 kilometers away in Montreal, damaged the city hall.
Wow.
So a magnitude 6 closer is bound to have possible interesting repercussions.
Yeah.
There's been magnitude 6 and up to 7 close to Quebec City on average every 70 years. The last one was in 1925, so maybe we're waiting for it. This should be happening. I think a week ago I checked, there was a magnitude 3.1 that was felt. It's not very big, but there's like 200 micro earthquakes per year in that part of the province. So yes, it's not an impossibility. It could happen.
It could happen. The earthquake takes place just 1 week before a referendum on Quebec's secession from Canada. Is that something that you see as a possibility for Quebec?
Just like earthquakes, it's about return periods. I think when you read the novel, you realize there's a lot about the history, the historical background of how things evolved the way they are, and the question I often get is, should they separate? And I refuse to give my personal opinions.
Okay.
I think the novel has enough information in it that it shows why that tension is there. Now, the future is always hard to predict. Who knows what will happen? But there's things that strike people. They go to Quebec, they arrive at the airport, and it says National Airport and National Capital Airport. And they say, "Oh, I didn't know Quebec was the capital of Canada." I says, "No, it's not. It's the national capital of what? Of Quebec." But nation, what is nation? Oh, well, that's a different story. Right? So everything is national in Quebec. So a lot of people see themselves as having a Quebec nationality, but they happen to be in Canada for economic reasons or historical reasons or other things. And it's hard to compare. It's hard to put that in perspective. I'll try to drive an analogy, but it's not a good analogy. In the US, moving to the US from Canada, the US starts to make sense when you think of the US as 50 countries that are united together. I mean, the mentalities, the thinking in California and Utah and Louisiana is not the same, right? They have very separate entities. But secession pressures don't seem to be an issue because there's a common fabric. There's a shared experience of what it is to be part of the US. People watch similar cultural events, TV programs, movies, sports events, Super Bowl, right? In Quebec, there's a different language, a different culture. People watch different TV shows. They listen to different music. They have different characteristics. So it's a little bit different in that sense. And there may be analogies in some parts of the US, but not that strongly different.
One of the characters in the book, James, is an engineer that heads into the epicenter of the earthquake on a reconnaissance mission. So I'm assuming that the wealth of his knowledge is taken from your real-life post-disaster trips?
Well, even though a book is fiction, it's got to be credible.
Sure.
So there's research in making a book credible, and I think you'll notice the book has a lot of historical information. There's a lot of things more than earthquake engineering, of course, and in fact it better be, because otherwise it'd be dry and boring. Everything has been researched to be factually correct, and of course I had an easier time to do the research on the engineering part, of course, because the seismology, earthquake engineering stuff is things that I'm familiar with. Now, everything that is an extrapolation and a speculation is just that, but it's anchored in some engineering guesses, right? So broken pipes in a building after an earthquake, that has happened, but if it happens in minus 40 degrees, well, you can guess that it will ice up the facade of the building and extrapolate from there what things would look like, right? But I want to make one thing clear. I am not the engineer in that book, okay?
Okay.
Because they're all characters of disputable character.
Really? You think James was?
He's got his flaws.
Well, everybody has flaws, but I think really out of everybody, he was easily the most noble character in the book, I thought.
I try not to be too hard on the engineers, I guess, compared to the others. But he still has
seemed
his
to
twisted
have-
side.
He seemed to have the most unselfish motives.
But in the end, it turns out that he is a little bit selfish,
little bit.
and he has his frustrations that he doesn't seem to be able to resolve,
Sure. But I thought compared to everybody else, he really comes out looking pretty good.
which is good. Otherwise, I might have lost a lot of engineer friends, right?
Yes.
The novel is about individuals of poor character from all walks of life. They have total disregard for the suffering of the population. They're pursuing their own goals. And I think that in itself is more devastating than the earthquake itself.
Yes.
Now, said like that, it sounds pretty bland, but I hope you had fun.
I did. Yeah, I did.
And I think the engineers who read the book, somehow, they like it too. It's been written for general public, but I think as engineers, we see different things in the book that maybe are playing at a different level.
Right.
And that makes it interesting for that. Interestingly, this took me 10 years to finish because of the heavy workload at the Earthquake Center. So in the meantime, in the process, I mean, I knew everything that was to go in the book, but still working on it. Hurricane Katrina happened.
Oh.
And remember Michael Brown, the Undersecretary of Emergency Preparedness and Response of DHS or FEMA? It was a big news item, right? And he was being criticized because he was not very responsive. CNN claimed that he had emails that he had sent back and forth between his staff and himself saying, should I roll up my sleeve above the elbow or below the elbow? And what's going to look better for the cameras and what have you. I was upset. I thought, geez, I've been scooped. There's one of the characters in my book, But then I thought, no, actually it's a good thing because it will make the book more credible.
More credible,
People
yes.
won't think I'm totally crazy.
Right, yes.
I have not gone over the edge. I mean, I've just taken individuals that are credible, possible individuals. There are individuals of dubious character in all walks of life.
Yes.
I hope we don't get there, though.
No, I hope not either. I hope not either.
But the point is it should be entertaining. It should be fun. That's the basic thing.
You said that you wouldn't ever stop writing, so my next question, do you have plans to write more fiction?
Yes.
Yes.
Yes, number 2 is finished. Novel number 2 is completed. It will probably come out in October of this
Really?
year, 2012.
Wow. What's it about?
I'll give you a scoop. I'll give you the title.
Okay.
It's called The Emancipating Death of a Boring Engineer.
Really?
Yeah.
Well, that sounds like a title that's fascinating that I would need to read.
Thank you. I think it's nice. It's got a nice hook to it. It's very different than the one you've just read. In fact, it's amazingly upbeat.
Oh, okay.
Has a nice ending too.
Great.
So it's very different. It's been written with a pen of a different color. But I will not tell you more than that. What I will say though is you may direct your listeners to the website michelbruneau.com.
Okay.
And by the time this podcast is out, there'll probably be a synopsis, there'll probably be information on the release date, there might even be a book cover, and I think the synopsis would be as appealing as the title, and hopefully people will want to read it.
Okay, great.
But I don't really say much while they're underway and while they're being written. Novel number 3 is in the works. I'm not 100% happy with it right now. Things don't change, I'll shelve it and move on to number 4, which I think is a great concept but extremely hard to pull. Number 5 I think is an easier concept. It's all in my mind, but it's going to be a truckload of work to do.
Wow,
in
you're
terms
really
of,
pretty far down that road.
That's as far as I am.
That's pretty far. That's pretty far.
But that's like, I can die before none of that happened,
Oh, wow.
I try to keep it a secret because I like to get the first impression. Here's what it is. Read it, tell me. And my wife likes it that way too, right? If I tell her the whole story and she reads it, I know all that stuff already. So that's why nobody knows, and until it's finished, and then when it's finished, it's going to get more broadcast, I guess.
Yeah. Okay, great. I'm looking forward to that.
So, michelbruneau.com.
Okay.
Easy to remember. The
Yeah.
problem is nobody can spell it.
Well, they'll be able to look on the website and see how to spell it.
There you go.
Our website, AISC's website. If you could only be an engineer or an author of fiction, which would you choose?
That's a very tricky question. That's like a Sophie's Choice, You've seen the movie, right? I don't think that I want to make that choice, or which side of the brain. I'm going to amputate you from the left side or the left side of your brain. Which part of your brain do you want to keep? I honestly can't decide. But I'll tell you what. If you encourage all the podcast listeners to buy 100 copies to give as Christmas gifts, maybe I'll make 1 million sales and I'll be an easier decision to make.
Okay, well, all the listeners heard that. 100 copies each.
100 copies each. And then that might be neither that or that, but I may be just prefer to retire, go on a beach and play ukulele all day. So that seems appealing very much too.
That does. That does. What's the one thing that you know now that you wish you had known at the beginning of your career?
I wish I had known myself better. That sounds crazy to say, but I'll give you a couple of examples. It sounds obvious, but people can't read your brain, right? Mm-hmm. Anybody can't read the other people's brain. My defective brain works the following. Suppose you come up with a great idea, and you'll say, let's do this. And I will say, oh, that's very good. Wow, yeah, indeed, there's all kinds of benefits, benefits A, benefits B, benefits C. I can see where this leads 5 years from now. This is interesting. But, oh, there's one thing maybe that we need to talk about because it's not so clear to me how this great idea will work. So all these things happen in silence within about 2 seconds, and then I'll say, how will this thing work? And then people say, why is he criticizing my ID? And so I have to learn, or I've had to learn to slow down and tell you all the things I've told you that I would not tell before, because I thought it's obvious it's a great idea, and then ask my question so that I can understand it as an even better idea. So that I think gets misunderstood as a criticism, right? Mm-hmm. So slow down, go through the steps, and don't create misunderstanding. And that's things that I think, some of these things take me 50 years to learn, right? I come from a city, Quebec City, where 99% of the people are from the same culture, speak French, so there's understood body language, there's understood there's things you don't even have to say that are obvious, right? Mm-hmm. So when you're in a small town, 500,000 people, but they all more or less think the same, you start further out in the conversation. So when I went to California, big multicultural city, I put myself into a number of situations where I was completely unaware of proper protocol. Mm-hmm. I must have offended tons of people accidentally, If I had known myself better, I could have probably managed these situations better. Mm-hmm. By the time you die, you know these things a little bit, but it's too late.
Right, right.
That's the problem with experience, It takes time to get.
So I have one final question for you. If you could pick just one accomplishment in your career to date, of what are you most proud?
A couple of things. I have 2 sons that are great young men, and they're responsible individuals. I get along with them smashingly well. We have a lot of fun together. They're engineers, not civil engineers, but one is a computer engineer and an electrical engineering, hardware, software side, and the other one is a mechanical engineer.
Wow.
But we don't talk about engineering, so we're having a lot of fun. And that's great. I think that to me is good accomplishment. Mm-hmm. The other thing is I am a grumpy pessimist of an individual, and yet in spite of that I managed to remain married to a wonderful wife. Some people claim she's a saint, mm-hmm. and to stay with me probably requires that quality. The thing with pessimists is they are convinced that, let me backtrack. You ask an optimist, you say, oh, you're an optimist. They'll say, oh yes, I'm an optimist. You ask a pessimist, you're a pessimist, they'll say, no, I'm a realist, right? They always think they're right. Yes. That's the problem. So I'm a pessimist. Now, technically, if you ask me what is my greatest accomplishment, I think that's for others to say. I don't know, because my judgment, my perception is probably incorrect. And I would prefer not to say, here's a great accomplishment that everybody else thinks it's garbage, right? All I'll say is I'm pleased if I can make a humble contribution to the field of engineering. If some of it is in the AISC specification, I'll be very happy. It's nice when an engineer sends you a photo, like I received a month ago. Somebody had done a perforated steel plate shear wall. Mm-hmm. The first one in North America. I thought, oh, that's nice. Mm-hmm. It's a nice thing to get photos like that because it has been built. Right? Mm-hmm. So that's enjoyable. It's nice when I received a photo of the temporary support of the new Bay Bridge between the Oakland and the Treasure Island, and then they have to create a temporary support, and that temporary tower had an eccentrically braced frame made with the links made of built-up boxes.
Oh, okay.
Right? So you say, oh, that's nice, that's great. It's so fun to see these things there, right? Mm-hmm. It's nice when out of the blue, somebody says, I'm using ductile design of steel structures, I love the textbook. That's great, you say, I could have made more money being a consultant, but this is nice to at least know it's been used and useful. Yeah. Uh-huh. It's nice when somebody say, I enjoyed your novel. Uh-huh. That says, oh, that was fun. It's nice to know it's been enjoyed, right? So I think there's a lot of things that are nice. Are they great accomplishments? I don't know. It looks like it serves a purpose, so that's nice for that. I will tell you though, my biggest disappointment. Oh, that's a change. That's a twist on your question, right?
It is. I'll have to start asking that.
Now, imagine you're into the best roller coaster ride in the world. It's going up, it's going down, it's going fast, all these turns, right? It's truly enjoyable. But then you see the end coming, and somebody tells you, that's it. It's a one-ride show. You can't go up a second time. What? This is so much fun. What do you mean I can't ride again? I think life is like a roller coaster ride. Mm-hmm. It's truly enjoyable, but the problem is, it's not, one ride is not enough.
Right.
I think we should have a chance to get more rides.
I would agree, yes. That would be great. It's been a pleasure.
It's been a pleasure. You've made me do something I rarely do. Just talk about myself, but I hope it was not grinding like a fork in a plate or something.
Absolutely not. Absolutely not.
This has been a presentation by the American Institute of Steel Construction.
Join us next month when my guest will be Dr. John Fisher, Professor Emeritus of Civil Engineering at Lehigh University.
For more information on AISC continuing education opportunities, please visit us on the web at aisc.org/seminars. And remember, there's always a solution in steel.